Um, Good morning, everybody. I guess you didn't party too hard at Offspring last night, so happy to see a few people in here. I'm Curt Barnard, and this is DawudGordon, and we're going to talk today about behavioral biometrics and applications for deception technology. Real quick, just to tell you a little bit about myself, I'm the founder of a small startup. We work with honeypots, but I've been working kind of in the space for about 10 years. Worked in defense and in venture capital for a little bit. But I took the last year off, more or less, to live on a sailboat, so I can also talk to you about digital nomad life a little bit, if you're interested in talking about that. But I built the company while living on my sailboat. So then I'll hand it over to Dawud, and he'll get us started with talking about behavioral biometrics.
Cool. Yeah, my name is DawudGordon. This is my Twitter handle, which is going to be important later. I'll bring it back up because that's where you'll be able to find some of the source for the demo that we're going to do and mess around with it yourself. In general, I'm an antique motorcycle repairman. I like to take things that are old and pretty and really poorly engineered and then pour all of my time into them. This thing still doesn't run. I've had it for like a year. In my spare time, I spent many years in machine learning research, specifically machine learning for helping machines understand human behavior. And I did this, my graduate studies at KIT in Germany and the ETH in Zurich, where I did a PhD in computer engineering at KIT. And now I run a startup in behavioral biometrics called 2 Cents that focuses on behavioral biometrics for enterprise employees. And so what I would like to do now is just, this was originally scheduled for a full talk, which we bumped down to a short one, so I'm going to try and give you quickly an overview of what behavioral biometrics is and how it works, because it's really relevant to understand that so we can apply it to deception technology. So the core of it is that every time you want to interact with a device or do basically anything in the digital world, the responsibility for identity security is on you. You have to do the work to prove to that system that you're the right person to do whatever transaction that was. And behavioral biometrics is a paradigm shift that looks to enable the device to learn to recognize you as a human being by your behavior, by what you're doing. And the reason we want to do this, if we can do this successfully, then we have something that is authentication, but it is invisible to you, so it doesn't have any extra workload, which means you can use it more. You can use it a lot more. It can be on all the time, so completely continuous, which really increases security of every system that we have now if we were to be able to do authentication or identity security continuously. And so, like I said, it's all behavior-based, and to a computer, this is what behavior looks like. So behavior is timestamp data, time series data of observations of the world as they change over time. And so what we're looking at here is motion data that came off of a phone that was in somebody's pocket, in my pocket, while I was walking around. And so when you look at it, you know, you can see some things about it. You can see that there's peaks and there's periodicity. But really, your brain was not meant to interpret this data the way it was meant to interpret my voice, for example. So it makes things a little more complicated when we as humans aren't really the best judge of that. And here's a great example. So this is me walking, and this is, for example, Curt walking. And you can see that these two signals, one off of my phone and one off of his phone, they're similar to each other, but they're also different. They're a lot more similar than they are different from each other, but there's definitely a difference. And so the challenge of behavioral biometrics is, given behavior, one slot is to be able to answer the question, did this come from the user that is authorized for whatever it is that's happening right now? Whatever that transaction is, or whatever that account is this the behavior that is authorized for that account? And so from a machine learning point of view, from a machine point of view, what you're doing when you look at this is you're looking at the signal and you're trying to say, like, okay, well, I see this little peak, and you're looking at features of this signal that you're seeing and trying to match it with features of one of these other two signals. And so that's exactly what a machine does, except the features that it's looking for are a little different. So here, for example, we're looking at the average of the signal or the variance of that signal across this little window, or we take the Fourier transform, which gives us the primary indicator of where the frequency is. So, like, what is the rhythm of somebody's walking? That's what that would tell you. And then using that, you would plot these out, and so the training process would say, like, okay, we have the red dots are me and the blue dots are Curt. And so machine learning, this is what all the machine learning is trying to do here, is trying to draw a line across that to say, if in the future, when we don't know what the label is, if we get a dot, if it's above the line, we say it's Dawud. If it's below the line, we say it's Curt. And so that is what behavior biometrics is, using the behavior to say if this is the user or not. The problem is that there's a lot of ambiguity. So this is what a visualization might actually look like. So this is not, this would be two-dimensional data only, which is like mean and variance, for example. The reality is you have many, many more dimensions, and you can use tools to squeeze them down into 2 dimensions so you can view them like this. Tease-me is one of those tools. And what you see is that this is a lot more, it would be much harder to draw a line here that would make any sense, right? You're just going to draw one line. And so what the industry is all about and what the machine learning is about that actually makes this be viable is the use of deep neural networks. And the reason that these are so relevant here is because deep neural networks allow us not to say we're going to look at the mean and variance of my gait and then the mean and variance of Curt's gait and then say how do they differ from each other, but say for Dawud's behavior, let's look at that behavior and let's learn about that behavior. What is it about it that differentiates it from everybody else's behavior? And this changes the ballgame drastically, so that from something that looks like this, which is very hard to separate, with those types of features, you can get something like this, which is much easier to separate, which is where you want to be, right? So this is how this technology has been evolving, and this is how we're getting to a point where we can actually use this in production to deliver value. Now, the problem is not everybody has a super unique gait, right? So some of us do, some of us don't. But even for that gait, which is super unique, for an individual that has a very unique style of walking, there's going to be somewhere, there's a lot of people on this planet, there's going to be somebody somewhere else that has a similar way of walking. And so how this actually works and makes sense is that we need to use every type of addressable behavior and model it all in parallel. So not just looking at motion, but also looking at that factored over location. Is this normal motion for this location? Is this the way this guy walks at work? So how does somebody interact with a touchscreen, looking at swipe gestures and typing into the touchscreen, using authentication, manual authentication that we do all the time as a label to tell us this is actually authorized behavior, continuously updating our models to learn new behavior, looking at it over time, app usage, mouse movements, speed, variability, cadence of typing. All of these are aspects of our behavior, and each one of them is a good indicator, but it's all of them together that actually make something that is viable as a tool that you would actually want to use in production and will actually be helpful. So I'm going to hand off to Curt here.
Okay, so I'm going to talk briefly about deception technology and like what it is, and I think most of you guys know that like right now it's mostly hype, but really like at the end of the day it's like honeypots, like that's pretty much it. But it's not just honeypots, like it's like honey asterisk, right? It's like honey networks, honey tokens, but I mean the hype engine's kind of out of control, but I want to just take a look at some like history of deception technology and deception methodologies to talk about like ways that it can be maybe a little bit more than just like Kippo honeypots. So to do that, I want to talk about some history, and I want to talk about maps for a minute. So there has been this like long-standing problem of people that build maps copying other people's maps and like reselling them. And it used to be very expensive to go out and do all the research to build these maps in the first place. So what map makers started doing is putting fake streets and fake towns in their maps. So then when they went and like looked at another map in the general store and it had their fake town in it, they could say, hey, I know that you're copying my map. So this famously happened in a town in New York called Aglow, which is featured on the right there, where somebody put this town in. It was an anagram of the map maker's names, and they put it in there. This was a funny case, though, because then somebody built a general store at this corner and bought this guy's map and then named their store the Aglow General Store because they didn't know what town they were in. And then somebody did copy their maps, and they said, hey, you have this town, and they said, no, there's actually this general store called Aglow General, so it's a real town. And then it made it on like every map after that, and then the general store went out of business, and so that was the only like indicator in the real world of the town, and so then the town disappeared again. It's actually like a known issue on like for like national maps that this town may or may not appear on your map depending on when it was, but it was never an incorporated town. So that's really interesting because, I mean, really what they were trying to do is, as soon as somebody knew that there were these fake towns built into maps, if they wanted to ensure that they were not going to incorporate this trap into their own map, they had to do all the work that you would normally have to do to build a map. They would have to check every single town, every single street. And so really what it did is it took this problem that was really easy, which is copying maps, and it suddenly made it just as hard as doing it all over again in the first place. And there's a more recent example of this. If you guys remember this kind of Bing fiasco, where when Bing was starting out and they were trying to catch up to Google, these Google engineers were under the suspicion that Internet Explorer was stealing search results using like an IE toolbar. And so they fed fake search terms into Google that nobody should ever search for and that are not actually existent on any web page, and had their Google engineers go home and use IE8 to do searches for it. And sure enough, days later it popped up in Bing, but this, whatever this word is, does not appear on this page. So Google said, "Hey Bing, how'd you do this?" And the answer was they were copying their search results through the IE toolbar. So really, this is what I kind of believe is like the inception of deception technology, is really trying to use this like information asymmetry to actually gain an advantage against someone that is trying to use or abuse your product, service, or what have you. But today it's pretty much just honeypots. So you guys have probably heard of like Kippo and like Open Canary. I'm not going to go into detail on any of these. There's a GitHub repo that has like 1,000 honeypots. There's tons of them. I'm not just going to sit here and list them to you, but feel free to go check these out at this GitHub address. But really what it comes down to is like the promise of deception technology kind of never has really materialized. I mean, honeypots became popular like 2 decades ago, or a decade ago, and nobody knew what to do with the data and how to use it in a meaningful way, and then they like fell out of fashion, and now like the H word is like kind of a dirty word, but suddenly it's not again for seemingly no reason. But there's some cool things about honeypots. So like when they are set up like correctly and well, you can get some really, really good high quality alerts. And like Open Canary makes it really easy to just seed these like Canary credentials and Canary accounts in places. So I definitely recommend checking out Open Canary. And the other thing that's really cool is like the ability to try to coax out intent from whoever is like trying to penetrate your network or abusing these honeypots. You can generate these like fake environments to try to figure out what they're like attempting to do and what types of data they're going after. And there's a lot of really great tools now to help because honeypots are cool again. So that's really nice. But there's some really bad stuff about honeypots. Like, I don't know if you guys have ever like booted up Kippo and like logged into it and tried to like just pretended you were in a real computer, but it falls apart like really fast. So if somebody's using like an automated script or something, like yeah, it's probably gonna fool like the script, but like a human being, like it just like doesn't pass muster. And the other part is that you have to like run an effective honeypot, you have to make fake data that looks real but isn't valuable, and that is like a hard problem. It's almost as hard of a problem as generating data that has like true business value in the first place. Now, in some cases, it's really easy. Like, if you're a credit card company, you can just, like, make a bunch of credit card numbers that aren't associated with any account. Like, that's kind of easy. But if you are, like, developing intellectual property for, like, a new widget, it's pretty hard to make, like, fake blueprints that are going to be compelling to someone to download. And so the more compelling you make it, the harder and more expensive it is for you to actually do it. And there's, like, this tipping point where, like, making the honeypot is just as hard as like actually like generating revenue from like your business. And the other problem is that you might actually let bad guys do bad stuff. So like, as you guys know, like the first thing that like malware often does is it's like a dropper and it downloads and executes another payload. So if you actually want to let it download and execute something, you have to let it make web requests, but those same web requests can launch like attacks against vulnerable web applications. So most honeypots have like some kind of like whitelist or something where they actually let some traffic through so you can download and execute the second stage. But as soon as you do that, you open yourself up to actually letting them do other bad things through your honeypot. So you don't want to do that, so you have to be really careful. But like this is like the promise of deception technology, right? It's like a game of Minesweeper where almost everything is a mine. That's like what they'll tell you. But this is like not actually what we have seen. What we have seen has been these like really low interaction honeypots. So, you know, the goal is to change the balance. So like, you know, they say with like bank robbers, they only have to rob one bank. How did I screw it up? They only have to find one bank and rob it one time, but like the cops have to defend every bank all the time. The goal of deception is to kind of change that balance. So that's where we'd like to kind of talk about behavioral biometrics for deception. Behavioral biometrics is a really interesting application here because you can potentially turn every single account into a honeypot account. These behaviors are super hard to spoof. You don't have to seed keys or like seed false credentials and see if somebody uses these false credentials. Just like there's only one behavior that's accurate, and it's really hard for someone to spoof that behavior. And it happens completely passively in the background. So we're going to show a demo of like a little proof of concept that we made, but I'm going to show you how it works a little bit first. So the way that we have this set up is there's a user that can log into an application, and it actually tracks their behavior and their like typing cadence, and Dawud can talk about that a little bit more. And then you have a behavioral authentication mechanism that if it detects that it is the valid user's behavior, it sends them to real data and allows them to perform real, like, protected, restricted actions. But if it detects that the behavior is not associated with the real user, it sends them to, like, a separate table in a database that has fake data in it and actually denies the protected action. And the interesting thing about waiting to do the denial on the protected action is that you can actually extract some adversarial intent. So let them go through the web application that does not have any real data, and then if they, in our case, want to make a transfer to a new bank account, then you know the account number that they want to transfer to, and you only block them at that point. So that's kind of the concept. So with that, we're going to go into the demo, and so I'll hand it over to Dawud to kick off the demo. But you'll be able to actually check out the page at this bit.ly address, and I think Dawud's going to tweet it afterwards, but we'll demo it here first real quick. Yep.
Yeah, well, so this is, the demo is a public repo on Bitbucket and then hosted on Heroku. This is Alexei, our engineer, 2 cents, who built this for us in his spare time, so thank you. And just before we get started, I just want to say that this is not the way you would really want to do this in production. So this is really a proof of concept. What we're using here is we're going to look at how I enter the password in terms of the timestamps, the relative timestamps of how I type my password and how long after the previous keystroke does the next keystroke happen. I did that about 100 times over the past week, which is then stored here, and it's all in JavaScript, so you can really go and look at it and see exactly how it's working. So we have 100 trajectories of me going through that password, and then we're basically doing something that is very close to like nearest neighbors, where we're using something called dynamic time warping as the distance metric. So we see somebody type their password, we say how close is that to these 100 instances that we've recorded in the past. If that closeness is closer than a certain threshold, we're saying, okay, this is the authorized user. If it's not, then we're saying this is not the authorized user. So I'm gonna go ahead and log in here. And as you can see, I am a total tool, and I have put my password on my monitor on a post-it note, which is exactly what you shouldn't do. But so this is the password that's right there, right? So when I go to log in, you can see here in my checking account there's about $35, which is a founder's salary, so that sounds about right. Not much I can do with that, right? So if somebody were to actually get in here, they would not be super excited about this. But if I go and transfer funds, let's say I'm going to give, say this is all Alexei's stuff, and I'm going to give him $34 for doing a good demo for us. Oops, I clicked off of it. 34. And I mean, this is real simple. This says success. So now what we're going to do is, obviously the password's the same, right? It's this password that's right here, and Curt's going to give it a shot.
Yeah, so if I like walk up to Dawud's screen and I see that he has a sticky note, and I try to type in his password that's on it, I log in, and it tells me that Dawud actually has $10,000, which does make me really excited, because I might want to transfer that to myself. So I might put in the same kind of thing. And it's not until this stage where I hit transfer that it actually says, please call customer service. And so at this point, it has extracted like some of my intent to transfer money from him, and has like sent me to not real Dawud's account, but fake data to allow me to kind of do that. So that's really interesting because it assumes that I know the correct password, but just don't have the right behavior. I'm still not Dawud. So that's really what we're talking about, where this is a little different from like a traditional honeypot because it's using behavioral analytics, but there are some ways to implement this type of technology in more interesting and compelling ways, and that's kind of what we were interested in exploring together. So,
does anybody want to give it a shot?
Volunteers can try it.
Yeah.
All right. We're really tempting the demo gods by doing this. But
So that's the password right there. The password is U1 with.
Man.
Boom!
You got me. Good job.
Good job, Leslie. All right, yeah. So I'm gonna tweet this. I'm gonna tweet this out after the talk. It's all up here on GitHub, and there's the Heroku app that you can go and try and mess around with it. And it's completely open source. Everything is done on the client side, so you can really go and watch exactly how the data is being interpreted and probably try and mess around with it. I'm assuming that this is not going to be super secure and that you will, with some practice, be able to get through. But in general, this is just a way to show that with behavioral biometrics, the biometric is independent of the credentials. So even if somebody knows the credentials, you still have an indicator that this is not an authorized user with an authorized account, which is really one of the biggest problems. And so until now, really, this technology has really been used in mobile e-commerce and stuff like that for just looking for fraud and in people buying things on accounts that aren't theirs, and this is just an example of how you could use it for deceptive tech that we think is really cool. Any questions? Yep. About, I'm sorry, cadence. Yeah, let's go take a look. And please correct me if I spout bullshit here. All right, so in here we've got this data.json, and this is a 2D array. And in this 2D array, what you're looking at is the nanoseconds of the keystroke data for me entering it. This array, you're seeing like one vector. That's me typing in the password is you, once. And these are, so the first keystroke happened 25.9 milliseconds after, the second one happened 25.9 after the first one, the next one happened 42.7 after the second one, and so on and so forth. So this is really a very, very simplistic way of doing it. It doesn't actually explicitly model the cadence, it doesn't model variability. All it's doing is, it's what's called a greedy type of classifier that makes the decision at the latest point possible with the raw data, which is the trend. So there's not actually any modeling happening here. It's just the classifier. But there are many, many other approaches. Like I said, this is not what you would want to do. We're not like giving away any secret IP. This is like not what you'd want to do. It just kind of works. Yeah. Thanks. No. I just typed this password 100 times, and we recorded it, and then we say, is what we've seen here very close to one of these 100 times? That's it. Yes. Yeah, you wouldn't want to use this as a product. Yeah. So you wouldn't want to use it like this, but the way like our products work is it sits on top of manual multi-factor auth, where you get like a prompt to your phone, a challenge that you have to deal with. So at the beginning, every time you log in, you're getting these prompts, and eventually those prompts just disappear because this becomes accurate enough that it can take over. The behavioral can take over from MFA. Yeah. It's like it makes the multi-factor auth become invisible. Like the system, the identity system asks us first, can we give this user a green light? And if we say no, only then does it fall back to the manual challenge.
Yeah. But to get to your question, using the MFA as a second factor, when he types in his password and then issues MFA, it saves that as like, now we have definitely validated that this is Dawud. And so that would save that as like one of these 100. And so that's how it built that model. So if it fails, it asks for MFA, and then it saves that when you answer correctly. Does that make sense? In this case, it would just send an MFA challenge again. Yeah. And yeah, we're out of time, so we're happy to answer more questions up front. But that's it for us.
Thank you, guys.